All right, on to number 4, and maybe 5 and 6. Number 4, which I hope you tried already, and something similar is going to happen to the last problem in number 3, where you've got an extra scalar multiple that you have to deal with. I'm going for some Christmas green, so I'm taking the integral of square root of 3x plus 7 dx, which I would want you to think about first as that's just algebra. Now, my only chance for u is right there. U equals 3x plus 7. I'm going to just write the du dx as separate right now. So I'm taking the derivative with respect to x, and that becomes 3 dx. This time I just didn't write the dx underneath the du, and then the next step move it over. I'm just going to write it as du equals 3 dx. I look at my original for my change one right there, and I see that I don't have that scalar multiple, so I want to move it to the other side and make it 1/3 du equals dx. This dx is represented right here, so now I can change this whole thing into terms of u. Rewrite it. Let's go with black. And now, in terms of u, I have 1/3 the integral of u to the 1/2 du. That's an easy integral. I have 1/3. The u becomes to the 3/2, right? I add 1 and I divide by 3/2, or hopefully you're all multiplying by 2/3. And now I'm going to get 2/9 back substitute 3x plus 7 to the 3/2 plus c. There is my antiderivative. Take the derivative of it to make sure that you get back to the original integrand. And number 5, which pause if you haven't paused. Try number 5. We're trying some trigonometric this time. I have sine 2x cosine 2x dx. In this case, I can use u substitution, because if I substitute one of those as u, either the sine 2x or the cosine 2x, when I take the derivative of that u, I basically get the other one. And I'm going to use sine as my u, so when I take a derivative, I don't get negative, but it won't matter. You're going to have to deal with negative somehow. So if I make that u, essentially all this will become du. So u equals sine 2x. This is where you got to remember that when you take the derivative and you have that little guy right there, that's going to be multiplied out as well. So I have 2 cosine 2x. And I'm just writing the dx out. I'm not making this as 2 steps. So right now I've got very close to the cosine 2x dx, right? Cosine 2x dx, but I've got an extra 2. So that's another scenario where I divide or move it to the other side. So 1/2 du equals cosine 2x dx. Now I can rewrite this thing only in terms of u. I've got 1/2. Remember, you should be pausing this sometimes if you're following along and just trying to do the next step. So 1/2 u, right, du. That's it. So I'm going to mark this up a bit here. My 1/2 du, right, is all this stuff, cosine 2x dx, right? And my u, this part, is this part. Saying those two integrals are ultimately the same once I substitute, and then I'm going to back substitute. So now I'm going to integrate, and then we'll get 1/2. When I take the integral of u, I get u squared over 2. And now, I'm green for some reason. I am going to clean this up and resubstitute or back substitute. So I have 1/4. U is sine 2x, so I can call this sine squared, because that's squared, 2x plus c, or 1/4, I want to do it this way, sine 2x squared plus c, but most often you will see it like that. Now, I would really like you to pause the video, take the derivative of this, and see if you get back, because I actually haven't checked any of my answers in this, to that, and you get the the same antiderivative slash integrand relationship that you should. All right, I'm going to move on to number 6. Number 6, our first quotient. There is no quotient property for integrals. Second semester calculus, as in second semester college calculus, you use what's called integration by parts. But still, u substitution is easier. In this case, we can u substitute. The one thing I notice is that this denominator, I think of as like the square root as being 1/2. The x squared plus 3 is 1 degree higher than the 4x. So I'm going to make u as being x squared plus 3. I'm going to take the derivative. I get 2x. I'm just moving the dx over. Now I have a sum match. I've got the x dx right here, the x dx. In the original integrand, I've got an extra 4. In my du, I've got an extra 2, so I can deal with both of those. So my first thing is to make this 1/2 du equals x dx. All right, now I'm going to do quite a few things to this to write it in terms of u only. The first thing is to make it red. The second thing is this 4 I'm going to deal with by bringing it outside the integral, so 4. And then I have to deal with this 1/2. Right, so ultimately I've got times 1/2. Now I've got the integral. My numerator is basically du, so I can think of it like that, right? Because the x dx. And my denominator is u to the 1/2. Alright, now before I integrate that thing, I'm going to clean it up a little bit because that looks a little weird. So my 4 times 1/2 is just 2. I don't want my u to the 1/2 like that because I don't really, it's still a quotient, so I want to make it a u to the negative 1/2. It's just using algebra. Now that thing should be easy to integrate. I got my 2. The integral of u to the negative 1/2 becomes I add 1, which is that, divide by 1/2, which is the same thing as multiplying by 2/1. And then plus c, and then I clean that thing up a little. Becomes 4. I'm going to back substitute as well. My u, which was x squared plus 3. X squared plus 3, all raised to the 1/2 plus c. Or you might write it as 4 times the square root of x squared plus 3 plus c. And take the derivative of that to check your answer. Make sure you get back to the original integral.